how to easily solve any forces problems involving tension. So here we have two different masses on a ramp angled at an angle of theta held by two different strings with different tensions. So the first thing we're going to do always is set up a coordinate axis. So we're going to set up and right as positive, down and left as negative. We're going to draw our free body diagrams angled at an angle of theta, so it makes it easier for us later. So here we can call this an angle of theta, which will make our T2 just straight to the right and our T1 straight to the left, and of a normal force going straight up. And then for M2, we're going to have very similar things. We can write FG1 here. And so here we're going to have, again, we're going to angle it at theta. FG2, we're going to have FN2, and then we're only going to have T1 going this way. Now that we have our free body diagrams, we can go ahead and write out our force equations. I just noticed this should actually be T2. But anyways, now we're going to write out our net force equations. So we always want to start off with the one that has less tensions acting on it. And that's going to be M2. So let's go ahead and write out the net force equation for that. We know that we have Fg2 sine theta minus T2 equals 0, which is really just 2mg sine theta equals T2. Since we started off with the one we know has less tensions acting on it, we automatically know T2. Now moving on to the next one, we have x of m1. And so we now know that this one is going to have Fg1 sine theta plus T2 is going to be minus T1 equals 0. Really what this is going to be is we know Fg1 sine theta is just mg sine theta. And we now know that T2 is 2mg sine theta. And we can move T1 on the other side. So we now know that T1 is equal to 3mg sine theta. And that's how you solve any forces problems. And if you follow this route, you can solve any problems involving tension. Okay, maybe not all.